the ALEKS Goal Topic, distinguishing compounds and mixtures. So to attempt this kind of problem, you need to understand the difference in the definition between an element and a compound. So an element is what we would define as a substance which cannot be broken up into anything simpler using any kind of chemical process. So whatever kind of chemical reaction you try and do to an element, you could form a compound or something, but you cannot break that element down into anything simpler. So for an example, an element would be something like, let's go high, gold. So that would just be the chemical symbol AU. And you could even show the state. It'd be a solid in its standard state. Or something else like oxygen. Oxygen's a sneaky one because it's a homonuclear diatomic gas. So it's two oxygen atoms bonded together to form a single oxygen molecule. So be aware, elements sometimes are formed as atoms like gold, or perhaps one of our noble gases like, let's pick on helium, would just be found as single He atoms, and they are gases, okay? But sometimes elements like to buddy up and form a molecule which may contain commonly two. You have these 7 homonuclear diatomics like oxygen, nitrogen, chlorine, hydrogen, for example. But sometimes more, like phosphorus likes to be in groups of 4. So the formula for phosphorus in its elemental state is P4, or sulfur is S6. Okay, so just because there's more than one element bonded together to form a molecule, it would still be an element because it is not bonded to anything different. That would be a compound. If you have 2 or more different elements, that forms a compound. So that is where you have 2 or more different elements bonded together, not a mixture. They have to be bonded together with chemical bonds, whatever the type those are, ionic, molecular, metallic if it's an alloy. So 2 or more different elements bonded together, and they will be in fixed proportions. For example, there is a difference between carbon monoxide and carbon dioxide. That is the proportion between carbons and oxygen atoms in the compound. And you can only separate the elements forming a compound together via a chemical reaction. So examples of elements then would be things like water. Water is one of those fun ones that we have a old name for rather than using standard chemical naming nomenclature. So water was H2O, liquid at room temperature and pressure, or ammonia if you want. Might as well bring that up, okay, because that's another name that you're expected to know which doesn't follow the naming conventions because it is been known for a long time. Ammonia, 1 nitrogen bonded to 3 hydrogen. That's usually a gas at room temperature and pressure, or something like carbon dioxide, CO2. Okay, so then if we look at these substances, these are sort of atomic view, microscopic views of what we imagine the substances to look like. And we have to work out if they're an element or a compound or a mixture. So we're going to assume a different color means a different element identity. So if we look at substance X, I'm looking up in the top left-hand corner, we have the gold ball and a red ball. So I could write a kind of chemical formula for that. Let R equal red and G equals gold. We have one compound Rg. So 1 atom of R bonded to 1 atom of G. Okay, so this is substance X, right? And if I look next to it, there's another one and there's another one, but then next to that, there is 2 golds bonded together, G subscript 2. Okay, so this must be a mixture, okay, because we have one, this is a compound, because it's 2 or more different elements bonded together, and the G2 would be an element, even if it is a molecule of 2 elements bonded together. That would be an example of a homonuclear. That means same element, diatomic, 2 atoms bonded together to form a molecule, and that's all I see in there. So we've got one compound, one element, and they're a mixture because that element and that compound, they're not bonded together physically, they're separated, right? So substance X, we assure, is a mixture. What about substance Y? Well, I see one compound here with a gold atom and a red atom, and that is all I see there. They are all the same. So that is completely consisting of a compound, nothing else mixed in there. Would help if I could type today, wouldn't it? So that is just a compound. So the red and the green atom, which are bonded together, you can only separate that bond by some kind of chemical reaction. Okay, if you heat it up, cool it down, that's a physical process, would not separate the red atom from the gold atom. What about substance Z? Okay, or Z if you prefer. So I see two gold atoms bonded together. So that would be G subscript 2, because the gold atom has the same element identity. They have two atoms of the same element bonded together. Even though it's a molecule, it is still classified as an element. A compound has to have two different elements to be a compound, okay? So that would be an element, an example of a homonuclear diatomic. So that is a element. Nothing else mixed in there. And then lastly, substance T. What have we got here? Ooh, that's pretty. So we have a compound here. If I was going to write a chemical formula for it, I would say it's GR subscript 3. So there's 3 red atoms for every 1 gold atom. Those are bonded together, so that would be a compound. And that is all that there is in that box. I don't see anything else. So I would go ahead and call that a pure compound. Okay. So just to reiterate, make sure we're happy with that, I'm actually going to get another one up just to see if we see anything that's confusing or not, as the case may be. So let's just refresh and see if we can work out what we have here a little bit more quickly. Okay, so substance X, if we look at that very carefully with my old eyes, that looks to me like we have 2 white atoms and 2 red atoms. So I would call that R2W2. Is there anything else in there? They all have the same composition. So I'm going to go straight ahead and say that is a compound. Okay, nothing else mixed in there. Substance Y, again, if I was going to write a formula for this, there's 2 red atoms bonded together in a molecule, so R subscript 2, and there's nothing else in there. So that is an element, is a homonuclear diatomic molecule, but both elements have the same identity, so it still is classified as an element. If we look at substance Z, very close up to the screen, if we look at this one at the top left-hand corner, the little Mickey Mouse type one, that has the formula. There's 1 red atom and 2 white atoms, so RW subscript 2 would be one of them. And then the buddy right next to it has got 2 red atoms, 2 white atoms. So remember, our definition of a compound is very specific, that the different elements bonded together are in fixed proportions. So we have different proportions between this molecule RW2 and this molecule R2W2. So there is 2 different compounds, at least in here. Let's call it compound 1 and compound 2. So if you have a mixture of 2 different compounds, well, that's going to be a mixture, right? So these compounds are not bonded together with each other. So we've got a mixture of 2 different compounds. And then lastly, this looks like a pure substance again. This must be a compound because we have RW2. Okay, there's only 1 type of compound in here. It's not mixed with anything else, so I'm going to go ahead and click that as a compound. Okay, so hopefully that is enough examples of that one for you guys to help you out with that question.